What does factorizing mean? Let's begin with a numerical example. For simplicity, let's take a simple sum. We have the following shown on screen. The two addends 15 and 6 have the number 3 as a common factor. Hence, we can write 15 as 3 5 and 6 as 3 2 to obtain the following shown on screen. If we pull out the common factor from each number and write it only once before the rest of expression that is written in brackets, we have the following shown on screen. Obviously, the result does not change, as now we have 3 7 is equal to 21. It is still the same, correct, result. We simply converted an addition into multiplication by highlighting the common factor of addends. This method is known as factorizing. The concept of factorizing can also be extended to algebraic expressions. We just need to identify the common factor and then isolate it from the rest of expression. By definition, factorizing is the inverse of expanding, consisting in the use of common factors to write an expression as a product of factors. In other words, factorizing means finding what to multiply together to get a new expression written in terms of these factors. This action is like splitting an expression into a multiplication of simpler expressions. The simplest factorization scheme is the one that involves three quantities, where one of them is a factor of the other two. In symbols, we write it as the following shown on screen. We can think of the term factorization as getting aside or isolating the common part of an expression. The common term is factorized while the rest of each term of the expression is written in brackets multiplied by the factorized part. The signs of terms in brackets do not change unless the common factor is positive or of unknown sign. Otherwise, if the common factor is negative, all terms in brackets change sign. Example 1. Factorize the following algebraic expressions. A. 3x plus 21x squared minus 11x cubed. B. 24x cubed y squared minus 16x squared y cubed. Solution 1. A. There is only one x as a common factor of the three terms in this expression. Hence, we factorize it to obtain the following as shown on screen. B. This time, there are more common factors than in the first example. In numbers, coefficients, we have 8 as common factor, as all numbers are multiples of 8. Moreover, there is an x squared and an y squared as common factors in variables. Therefore, we factorize all of them to obtain the following as shown on screen. A good indicator, which shows that you have factorized an expression correctly, is when you don't have any more operations to do in the expression that remains in brackets after the common factor is factorized. Thus, for both expressions in brackets obtained in the previous example, there are no more operations to do in the part contained in brackets. You may want to factorize a negative term, as said earlier. Let's illustrate what happens with the expression in this case with the expression b. Thus, if we choose to factorize the term minus 8x squared y squared instead of 8x squared y squared, we would obtain the following as shown on screen. Obviously, the two factorized expressions 8x squared y squared, 3x, 2y, and minus 8x squared y squared, 2y, 3x, are equivalent. We can look at the 8 special identities explained in the previous tutorial in reverse to obtain some useful factorizations. 1. We have the following shown on screen. 2. We obtain the following shown on screen. 3. We obtain the following shown on screen. 4. We obtain the following shown on screen. 5. We obtain the following shown on screen. 6. We obtain the following shown on screen. 7. We obtain the following shown on screen. 8. We obtain the following shown on screen. 9. We obtain the following shown on screen. 10. We obtain the following shown on screen. 11. We obtain the following shown on screen. 12. We obtain the following shown on screen. 13. We obtain the following shown on screen. 14. We obtain the following shown on screen. 15. We obtain the following shown on screen. 16. We obtain the following shown on screen. 2. Factorize the following algebraic expressions. A. For by 3 minus 12x squared plus 9x. B. x3 minus x minus 6. Solution 2. A. First, it is easy to identify an x as a common factor. Thus, we write the following as shown on screen. Now, if you look at the expression in brackets carefully, you will identify the expanded form of the special algebraic identity, 2x minus 3 squared, because we obtain the following as shown on screen. Hence, we can write the factorized form of the original expression as the following shown on screen. B. We can write this expression as the following shown on screen. Because the first two terms represent the expanded form of the algebraic identity, we obtain the following shown on screen. On the other hand, we can write in brackets the last two terms as well, by leaving the minus sign out of brackets. In this way the expression in brackets changes sign to become the following as shown on screen. Now, we can see that there is a new factorization available. We can factorize x minus 2, as it is a common factor of the big expression. Thus, since x minus 2 equals 1, x minus 2, we obtain the following shown on screen. That is all for lesson 6.4.1. To continue this tutorial, please watch 6.4.2, the meaning of quadratics. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.